I want to do one more problem involving the distance function, and then I want to talk about the midpoint formula. So consider these 3 points. I'm going to label them A, B, and C. So let's let A be -5, 1. B be the point -1, 3. And C be the point 0, 1. The first thing I want to do is I want to plot the points. The second thing I want to do is create a right triangle, or just create a triangle with the points. So the points will be the vertices of the triangle. The next thing I want to do is I want to verify that it's a right triangle. And then I want to find the area of the triangle. Okay, let's get started. So let's plot the points first. So maybe you should copy down these points and copy down the 4 things we need to do. That way you can see it on your paper and I don't have to scroll back and forth too much. So we have -5, 1, -1, 3, and 0, 1. I'm going to scroll down and let's make the X and Y axis. It doesn't have to be perfect. So this is our X axis. This is our Y axis. And let's start with the first point, -5, 1. So remember, -5, 1, this is the X coordinate. So we need to go to -5. Let's just make some tick marks here. That's 5 to the left. And then this is the Y coordinate. So we need to go up 1. And here's our first point. We can even write -5, 1 above it, or you could put A, because I think this is what we called A. So in fact, so I don't take so much space, I'm just going to put A there. The next point is -1, 3. So -1 and up 3, this is the point B. And then the last point, C, is 0, 1. Now remember, 0 is the X point, the X coordinate, and we go up 1. So this is the point C. Now let's connect these 3 dots like this. Now looking at this, it does kind of look like a right triangle. I would say that this is the 90-degree angle right here. But you know, we have to be careful. We have to make sure that it's a right triangle. So we've done parts A and B. How do we verify that it is a right triangle? Well, for every right triangle, and only for right triangles, we have the Pythagorean theorem. And the Pythagorean theorem says, if you have 3 sides of a triangle, since this is capital C, I'm going to make the side opposite to it lowercase c. The side opposite to this point A, I'm going to call this line right here, this line segment A. And this line segment, I'm going to call it B. And it says that if you square the shorter sides, add them together, you should get the square of the longer side. And to me, it looks like this is the longer side. So c squared plus a squared is b squared. Now you probably memorized it as a squared plus b squared is c squared. And that has to deal with how you label your sides. Because I labeled my points like this and I labeled my sides opposite, it's the same formula, it's just that I put A, B, and C in a different order, because my longest side, to me, it looks like it's going to be A to C. Now we don't know for sure, this is just by the picture, but what we need to check is that for each one of these sides, if we square two of them, the shorter sides, and add them together, we get the longest side. So that's what I want to check. So let's find the distance between A and B, the distance between B and C, and the distance between A and C. And let's take the two shorter ones, we're going to square them, add them together, and see if we get the square of the longer side. Okay, so let's start with the distance between A and B. So what's the distance between points A and B? And we're going to label it like this. So the distance formula, if you remember, you subtract your x coordinates, square them, subtract the y coordinates, square them, add that together, and then take the square root. Now it doesn't matter which point you label A and B, but we've already decided earlier, but if we were just dealing with any 2 points, it wouldn't matter. So we're going to let A be the point -5, 1, which is x1, y1, and we're going to let the point B be -1, 3, which is x2, y2. And we're just going to plug all this information into this formula here. So the distance between A and B is the square root of -5 minus a -1 squared plus 1, so y1 minus y2 minus 3 squared. What do we get? Well, remember when we subtract a negative, it's the same thing as just adding these two. So we'll get -4 squared plus -2 squared, and we take the square root. So we get the square root of 16 plus 4, which is the square root of 20. I'm actually going to leave it like this for right now, not worry about it. So that tells us what the length of C is. So we're going to say C is equal to the square root of 20. You might even want to circle this in your notes so you know where it is. And now let's find the distance between any other points, any other 2 points. So let's go with A and C. So let's find the distance between A and C. So the distance between points A and C. So remember that A is the point -5, 1, which I'm going to label this as x1, y1, and C is the point 0, 1, which that's going to be x2, y2 for our distance formula. So the distance between A and C is the square root of x1, which is -5, subtract x2, square it, plus 1 minus this one, which is 1, square that. This one's actually not too bad. It's the square root of -5 squared plus 0 squared, which is the square root of 25, which you can leave it like that, but that's also equal to 5. So the distance between A and C is 5. And let's look back at what we called this line segment, the distance between A and C. That's line segment B. So I'm going to say B is equal to 5. And I'm going to circle this one too. We have to find the distance between B and C. That's the last thing we need to find. So let's write this. What is the distance between points B and C? Well, B is -1, 3, which we'll label this one as x1, y1 for the distance formula. And C is 0, 1, which again is x2, y2. And now the distance between B and C is the square root. We take x1 and subtract x2, so that's -1 minus 0 squared plus y1 minus y2. So we get the square root of -1 squared plus 2 squared, which is 1 plus 4, which is the square root of 5. So the line segment from B to C, we found B, we found C, so this is going to be A. Lowercase a is the square root of 5. Let's circle this one. Now we want to verify that this is a right triangle. Okay, let's put all three of these links we found down here. We said A is the square root of 5, B is, and C is. I believe we said B is 5. Let me just scroll back up. B is 5, and what did we say C was? The square root of 20. Okay, let's write that down. B is 5, C is the square root of 20. Now you can put this in the calculator to get an idea of what the square root of 5 is. So square root of 5 is about 2.24, and the square root of 20 is about 4.47. You can see that 5 is the biggest number, which tells us that the length B, that side with B on it in the triangle, is the longest side. So what we want to do is we want to see if we square A and if we square C, the two shorter sides, this 2.24 and this 4.475, do we get B squared? That's the question. If we get the right answer, if we add A squared to C squared and we get 5 squared, then we have a right triangle. If we get anything other than B squared, then we do not have a right triangle. So, and I'm actually going to use the exact measurements, because if we don't use the exact measurements, then we will run into a problem. We won't get the exact numbers because we're using estimates. This is a rounded number, so we're not going to use these. So A is the square root of 5. I'm going to square that. I'm going to add it to C squared, which is the square root of 20. Is this equal to B squared? Well, B was 5, and we're going to square that. So what we want to know, if we squared this, which is 5, is 5 plus, well, the square root of 20 squared is 20. Is 5 plus 20 equal, well, 5 squared is 25. Is 25 equal to 25? The answer is yes. So it does form a right triangle. So this implies we have a right triangle. Okay, so again, how would we know we don't have a right triangle? So for example, now this is not the same problem, I just want you to know for your homework or any other time that you want to figure out if you have a right triangle. Let's say something like you get A is the square root of 18, B is the square root of 30, and C is the square root of 2. Let's say you got these three measurements for your sides. Well, you can see that 18 and 2 are less than 30, so again, this would be the biggest side. And you would say, okay, is A squared plus C squared equal to B squared? Well, A squared is 18, and if I add this one squared, that would be 2, which is 20. Is that equal to this side squared, which is 30, which is not true. So you see that you didn't get 30, which tells you you wouldn't have a right triangle. So if you had some points that gave you that the distance between these 3 points were given by these 3 measurements, then you say, no, we don't have a right triangle. But in our case, the problem we just had, we do have a right triangle. Okay, and so the last part of this problem was to find the area of the right triangle. Let me just scroll back up so we can see that problem. You should probably have it written down. Sorry about, I have to scroll up all this way. Yeah, so this is the last thing we need to do. Find the area of the triangle. So find the area of a triangle, you have to remember the area formula. So let me scroll down. So the area of a triangle, let's write this here, what we're trying to find. So we want to find the area of the triangle. You have to remember the formula for the area of a triangle. So the area of a triangle is equal to 1/2 the base of the triangle times the height of the triangle. So let me give you an example of just a random triangle. So if this was the triangle we had, this doesn't really have straight lines, does it? Let me do a better job. So let's say this was the triangle we had. We have to figure out which side we want to be the base. And I would just say the one here is the base. So any side can be the base. But let's just say this one is the base. Okay? And then we have to find the height of the triangle. So we would have to make a straight line that's perpendicular, which means forms a 90-degree angle with the base. And then this length right here is the height. And so whatever this length is, times the base, if you multiply those two numbers together and then divide it by 2, you'll have the area. Now, if you don't have a right triangle, finding this length could be difficult. But if you have a right triangle, then it's going to be very easy because you already have 2 lines that are going to be perpendicular to each other, which is what we have. So remember we had a triangle that looked like similar to this one, but we know that it had a right triangle. This was a right triangle here because the longest side we said was 5, and then we said that, let me just scroll back up, we had A, B, and C. I believe I labeled, sorry, I'm gonna have to look back at this triangle. So we're gonna have to scroll all the way up just so we can see, here it is. So we had A, B, C. So B, which was our longest length, was right here. C was here, and A was here. So I'm gonna just redraw this triangle, but what I'm gonna do is I'm not gonna put these axes. These don't really matter. What matters is the lengths of the sides. So let's write what the lengths of the sides are and find the area. So let me scroll back down. Okay, so we had A, B, C. We said that this length was 5. The other 2 lengths were right here, square root 5 and square root 20. So let me write those. This is the square root of 20, and this is the square root of 5, because this is side A, this is side C, and this was side B. Now we want to find the area, and like I said, we could choose this one to be the base, but if we choose this one to be the base, we need a height, which means we need a side perpendicular to this base. Now, it would be easier for us, because we would actually have to do some work to figure that out, to rotate this triangle so that the base that we have a line that's already perpendicular to it. So let's rotate this triangle 90 degrees. We can flip it clockwise or counterclockwise, it doesn't matter. So what I'm going to do is I'm going to put the square root 5 here. Yeah, square root 5. Then the square root 20 here. and 5 here. So now this right triangle, you can see that what I've done is I've just flipped this triangle, rotated it 90 degrees. So then this side is now here, this side is now here, and this side is here. So the area of this triangle is 1/2 base times height. And now we can let this be the base. So this is 1/2 square root 20 times the height. And the height is going to be the square root 5. All right, now you could leave it like this. You could also say that this is 1/2. And when we have square roots, we can put them under the same square root. So that's 20 times 5, which is 1/2 square root of 100. And 100, can you take the square root of 100? You get 10. So then you get 1/2 times 10, which is 5. That is the area of the triangle. Okay, now notice that we did get the same number as the length of one of the sides, but that is not always true. So don't assume that it's the length of the largest side. You have to follow this formula to figure out the area. Okay, let's move on. Let's talk about the midpoint of a line segment. So that's our next topic, the midpoint formula. Now what I'm going to do is I'm going to draw a picture. Here I'm going to give you the x and y axis. And I'm just going to give you 2 random points. Let's say I give you a point here and a point here. Let's call this point A and this point B. And what I want to know is if I form a line from point A to point B, a straight line, although I have trouble drawing straight lines, let's say that's a straight line. How do we find the midpoint, or the point right in the middle of this line segment? So it looks something like right here. Let's call this point C. This is what we call the midpoint. So the midpoint of the line segment AB, so this just means the line from A to B, is the point on the line segment that's the same distance from A as B. How should I phrase that? It's the same distance from A and the same distance from B. In other words, the point that is right in the middle. So this distance here from A to C, let's call it D. This length, you want it to be the same as the length from C to B. You want these lengths to be equal. So how would we do that? How can we find a point that's in the middle of this line? Well, what you can do is you can say, well, we want D, which is the distance between A and C, to be the same as the distance between A and B. Now this is explained really well in your book, and I'm going to try to explain it as well. So we're going to write the distance formula. And so maybe we can figure out what needs to happen to find this point. So the distance from A to C, well, first we need to label A and C as x1, x2, and y1, y2, and things like that. So let's let I'm going to let this be x1, y1. So this point right here, this is x1, y1. And then I'm actually going to let this point B be x2, y2. And this third point, the one that we're trying to find, we can label it x3, y3, but I'm just actually going to put x comma y. So A is x1, y1, B is x2, y2, and then C is x comma y. Now the distance D between A and C, well, how would we find that? The distance is the square root. Well, remember the distance formula. We subtract the x coordinates. So that's x1 minus x squared plus, then we subtract the y coordinates. So y1 minus y squared. And this is what we're labeling just the length d. And the distance between, this should be between C and B, because we want this distance from A to C to be the same thing as from C to B. So we want this length to be the same. So we need to figure out the distance between C and B. So the distance between C and B is equal to the square root. I'm going to do exactly what I did before. I'm going to take the x coordinates. So I'm going to say x minus x2 and then I'm going to subtract the y coordinates. So y minus y2 and because we want these lengths to be the same, we set these two square roots equal to each other. So these square roots are the same. Well, since these square roots are the same, then we can square both sides. If this is equal to this and their squares are equal. So in other words, we can get rid of this square root. So I'm going to erase this. There's no reason to put this here if I just square both sides. And then you can see that in order for these two things to be equal, then this piece will need to equal this piece. The difference between these x's has to be the same. And this piece will have to be equal to this piece. So then x1 minus x, this should be equal to x minus x squared. So these two pieces are equal. And at the same time, the ones in red, the y1 minus y squared needs to be equal to the y minus y2 squared. And since we got the squares on both sides, how about we take the square root? So if we take the square root, we can just worry about the positive square root. So let's take the square root of both sides, get rid of this here. And these parentheses aren't really doing anything for us. We can get rid of these as well. Now what I'm going to do, because I want to find the midpoint, this point in the middle, which I called C. C, remember, is equal to x comma y. So let's solve both of these equations because I have two equations. Let's solve them for x. So what I'm going to do is I'm going to move this x. I can move it to this side or I could move this one over here. I'm going to move this one to this side by adding x. And I'm going to add y to both sides. By doing that, let's see what we get. So I get x1 is equal to 2x minus x2. And then I get y1 is equal to 2y minus y2. And now let's solve for x and y. So my next step, let me put this in red because the y's were in red. Now solve for y. So I'm going to move this y squared to the other side. I'm going to move this x squared to the other side. And then I'm going to divide by 2. So you'll see that you get x is equal to x1 plus x2 over 2. And y is equal to y1 plus y2 over 2. So this is the x and y that you need to find for your point C. So C is equal to x comma y. This is your midpoint. All you need to do is if you're given 2 points and you want to find the midpoint, you just need to add the x coordinates of those 2 points and divide by 2, add the y coordinates and divide by 2, and then you have your midpoint. So maybe you should write this down. You should say that this is how you find the midpoint. Now in your book, they label the midpoint as M. Since midpoint starts with the letter M, instead of using the letter C like I used, they use the letter M. So you'll see that M is equal to x comma y. But they'll tell you they're trying to find the midpoint. So let's do an example. So let's scroll down here. Now you don't have to remember all of these steps to get here. I just wanted to show you how to get here. This is what you need to memorize, how to actually find a midpoint. And we're going to do a couple problems, so it's not difficult at all. I think it's actually easier than the distance formula. Okay, so let me give you 2 points. Let's let A be equal to the point 3, 4. And let's let B be equal to -1, -1. So here I'm giving you 2 points. Let's find the midpoint. Now to find the midpoint, you don't have to draw a single thing, but I'm going to draw it just so we understand what we're doing, and maybe we can even make a guess as to what we think the midpoint is. So I'm going to draw the x and y axis, just really quick, and I'm going to plot these 2 points. So 1, 2, 3, 1, 2, 3, 4. Here's the point A, and the point B is -1, 1. So to find the midpoint, what we're doing is we're connecting points A and B with a line segment, and we're finding the point that's halfway between A and B, which I labeled C, but you can call it M or whatever letter you like. This point is the midpoint. And what I think the midpoint is, just by looking at this, I think it's somewhere in the first quadrant. So I think that the point has a positive x and a positive y, because this is quadrant 1. And you can see that I have a lot of line over in quadrant 1 and just a little bit of line in quadrant 3. So I think the midpoint should be in the middle. And in fact, I think it's going to be somewhere between 1 and 2, and maybe 1 and 2 here. And let's see if I'm right. So C, which is going to be our midpoint, C is equal to the point x comma y, where x is x1 plus x2 over 2, and y is y1 plus y2 over 2, and A, we're going to label this one as x1 comma y1, and B is x2 y2. So these 2 points here. So let's just plug this information into x and y. So I need to take x1 and x2, which is 3 and -1. I need to add them and then divide by 2. Maybe I'll leave that here. So x is equal to 3 plus a -1, which is x, plus x, so this x1 and x2, add them together and then divide by 2. So then we get 2 over 2, which is 1. So now we know this number, this is 1. Now let's find the y. So y is equal to y1 plus y2 over 2. So let's erase all of this here. I'm going to take this number 4 and add -1 to it. So 4 plus a -1 over 2. This is 3 over 2, and I can leave it like that. Or if you want to, you can say 1.5. So the point C, which is our midpoint, is equal to 1, 1.5, which is kind of what I was going with, right? I said it looked something like right around here, and if you look at it closely, to me it does look like I put more line here and less line here. So what they're saying is the midpoint is 1.5, so right here. That's the midpoint, and that looks correct to me. Let's do one more, just for practice. And this time we're not going to plot anything. So I'm going to let A be the point -7, 10. And let's let B be the point -8, 19. Can you find the midpoint between A and B? So I'll give you a minute. In fact, you should pause the video and try to find the midpoint yourself, and then just check to see if you get the same answer as I do. Okay, let's find the midpoint. So A, which is -7, 10, this is x1, y1, and B is -8, 19, we're going to call this x2, y2. And again, it doesn't matter if you label A as x2, y2 and B as x1, y1. You're going to get the same answer. So our point C is equal to x1, -7 plus -8 divided by 2, comma, 10 plus 19 divided by 2. So let's clean this up. This is -15 over 2, comma, 29 over 2. Now this is perfectly fine. Your homework might ask you to leave something as a fraction, which is this is how you're going to write it, or it might say write as a decimal. So you need to be careful and read the directions of what your homework says. But 15 divided by 2 is 7.5. I've got this negative here, so this is -7.5. And 29 divided by 2 is 14.5. So either one of these will work. And if you want, you can plot this and see if it looks correct to you. But this is the midpoint of these 2 points, A and B.